Alright, let's start with the first question. Multiply and simplify if possible. So here we are going to use the rules of multiplication for radicals to multiply these two radicals. So anytime you have a radical with the same index, in this case it's 2 and this one is 2, so we have a square root of 6 times square root of 24. We can always multiply the inside. So let's go ahead and write square root of 6 times square root of 24. Now you can always start by multiplying the inside, but also you can try to simplify. Like 6 is 2 times 3 and 24 is 4 times 6 or 2 times 3. What I like here is the 4, right? The 4 will come out as a 2 because square root of 4. So, I can write this as square root of 2 times 3, which is 6. So, it's not helpful to change this to 2 times 3. That was the same. But the 4 now will come out as a 2 times square root of 6. So notice that I have a 2 which will stay outside. Now I can multiply square root of 6 times square root of 6, and I can multiply the inside. 6 times 6 is 36. And of course 36 is a perfect square, and square root of 36 is 6 because 6 times 6 is 36. So that would be 2 times 6 equals 12 as the final answer. So here this whole thing is just 12. Let's go over this one more time. So you can multiply 6 times 24, but you will end up with a big number. So it's better to try to simplify first. And the best way to simplify is the 24 because it's 4 times 6. Now 4 is a perfect square. It will come out as a 2. And then you will end up with square root of 6 times square root of 6. And that's easy because 6 times 6 is 36, and 36 is a perfect square, and we know that 36 is 6 times 6. So therefore this will come out as 6, and 2 times 6 is 12. Let's look at the second question. Simplify by factoring. Notice here we have a cube root outside the radical, so that's a cube root here. We have a negative sign. 27 is nothing but 3 times 3 times 3. So that's 3 to the power 3. X9 is also a multiple of x cubed because x cubed times x cubed times x cubed is x9, and then y is by itself. So here's what we can take outside the radical. Negative sign can go outside the radical because negative times negative times negative is negative, so we can pull out the minus sign outside. Now here, if you want, we can divide this 3 by this 3. What is 3 divided by 3 is 1, so 3 to the power 1 will come out, so we don't have to write 3 to the power 1, we just write 3. So this 3 cubed, this 3 will come out because we can divide the exponent by the index, and that would simplify to 3. Same here, we can divide 9 by 3. 9 divided by 3 is 3, and that whole thing will simplify to x cubed, except for the y. The y cannot simplify, so y will stay inside the radical, and this would be the final answer. So in a problem like this, if this is a cube, we would like to make those exponents as a multiple of 3 if possible. Well, 3 is a multiple of 3 because 3 divided by 3 is 1, so we don't have to write 1 here, we just take the 3 outside. X to the power 9. 9 is a multiple of 3 because 9 divided by 3 is 3, so we change that x to the power 9 outside the radical as x cubed. Now y is to the power 1, and 1 divided by 3 is not going to simplify, so we'll keep the y inside the radical, and that would be the final answer. So here we simplify this to come up with minus 3 x cubed and then cube root of y. Number 3, how do we subtract these radicals? For a student who never studied about subtracting radical, you probably would go and subtract 12 minus 75 and you think that would be the answer. Of course, that's not right. The way to subtract radicals is to try to simplify the radical first. So our First step is to simplify the radicals, which is 4 times 3, and 4 is a perfect square, will come out as 2. So this will end up with 2 square root of 3. On the 75, this can be written as 3 times 25, because 3 times 25 is 75. The 25 is a perfect square and will come out as a 5. So here minus 5 square root of 3. Now these are called like radicals, and now we can subtract. We can subtract because we have the same radical 3 here, the same radical 3 here. We can subtract their coefficients. What is negative 5 plus 2? Or 2 minus 5? That's a negative 3, and then we keep the square root of 3. So think about this as 2x minus 5x, and the answer is negative 3x. Well, x in this case is square root of 3. Okay? So to subtract square root of 12 minus square root of, we have to simplify the radical first. By simplify means change the 12 to 4 times 3, take the 4 outside as 2, and that's how we simplify the square root of 12. By simplifying the square root of 75, we change it to 25 times 3, take the 25 outside as a 5, and now this is written in a simplified form. Since these two radicals are exactly the same, then we can subtract the coefficient, and the final answer is minus square root of 3 square root of 3. Okay? So that would be your final answer, minus 3 square root of 3, and this cannot be simplified any further. Multiply and simplify if possible. So we can FOIL here. We can multiply the 5 by 4, multiply the 5 by 3 square root of 7. We can do the same, minus 3 times square root of 7 times 4, and minus 3 square root of 7 times 3 square root of 7. So we have to do 4 multiplications here. The easy one is 5 times 4. That's 20. Now 5 times 3 square root of 7. You cannot multiply 5 by the 7 because that's a radical. So we only multiply 5 times 3. So that would be 15 square root of 7. Here we cannot multiply the 4 times square root of 7. We only multiply the 4 by negative 3. And that's going to be negative 12 square root of 7. Now here is the nice part. You're going to go negative times positive. That's negative. 3 times 3, that's 9. Now square root of 7 times square root of 7, we can multiply the inside. 7 times 7 is 49. Now we can simplify. These are called like radicals and can be combined. So we have 15 apple minus 12 apple. That's 3 apples. So we have 20 plus 3 square root of 7. Now this one, what is square root of 49? The number that 49 is a perfect square. 7 times 7 is 49. So this will come out as 7, and then you multiply by negative 9. That would give you negative 63. So now notice that 20 and negative 63 are like terms, can be combined, they're opposite signs, so you subtract negative 43, right? Because 63 minus 20 is 43, but this is more negative, that's why I have negative 43 plus 3 square root of 7. Now this we cannot combine anymore because these are unlike terms. This is a radical, and here there is no radical. So this would be the final answer. So basically we multiply 5 times 4, that's 20. 5 times 3 square root of 7, 15 square root of 7. Negative 3 square root of 7 times 4, negative 12 square root of 7. And negative 3 square root of 7 times positive 3 square root of 7, that would be negative 9 square root of 49. But square root of 49 is 7. We take the 7 outside, multiply it by negative 9. That's how we got the negative 63. 15 square root of 7 minus 12 square root of 7. We subtract the coefficients. 15 minus 12 is 3 square root of 7. 20 minus 63 is negative 43 plus 3 square root of 7 as the final answer. How do we rationalize the denominator? What do we mean by rationalize? Remove the radical. It means remove the radical, and in this case from the denominator. Remove the radical from the denominator. That's what That's what we mean by rationalize. Remove the radical. How do you move that? You can't just remove the radical and take it out to the numerator or something. We need to multiply up and down by the, in this case, square root of 3y over square root of 3y. Why did I choose to multiply by square root of 3y? Because this is a square root, and if you multiply the number by itself, it becomes a perfect square, and that would simplify the radical. Let me tell you what exactly I mean by this. When you multiply fractions, you multiply straight across. So 15 and the square root of 3y, I cannot multiply 15 times 3 because this one has a radical, this one does not have a radical. So I keep it as it is, 15 square root of 3y. But in the denominator, they both have radicals, so I can multiply the inside. So that would be 9y squared. But 9 is a perfect square, will come out as 3. Y squared is a perfect square, will come out as y. So here's the final answer, 15 square root of 3y over 3y. Is it the final answer? Looks like we can simplify more. What is 15 divided by 3? That's a 5. So the final answer would be 5 square root of 3y over y. So 15 is 5, 3 is 1. Divide up and down by 3. 15 by 3 is 5, 3 by 3 is 1. So y is left in the denominator by itself, and in the numerator we have 5 square root of 3y. And we satisfied the question, rationalize the denominator, no more radicals in the denominator. So the final answer would be 5 square root of 3y, and the whole thing is over y. No more radicals in the denominator. Now how do we solve? And remember, solve means we have to find the numerical value of x. Like your final answer should look like x equal some kind of number or constant or whatever. So let's take a look here. Radical. How do we take care of that radical? We have only one option, is to square both sides. So let's go ahead and square both sides. So we have square root of 2x plus 1. The only way we can get rid of the radical is by squaring it. But we have to square both sides. The easy part is the right hand side, because 7 times 7 is 49. Now here, what should we do? You square this and you have a radical, they cancel each other. So the radical and the square cancel each other, and then we end up with 2x plus 1. Now it's very simple to finish this problem. Subtract 1. 2x equals 48. Divide both sides by 2. X would be 24. We are done, but we must go back and check. Always when you square both sides or change a radical, to simplify it, you square both sides, you need to go back and check. So let's go and check. 2 times 24 plus 1, is it equal to 7? Yes. 48 plus 1 is 49, and square root of 49 is 7. That's right. So x equals 24 is the solution for this problem. X equals 24 is the final answer. Another solving problem, except we have x on both sides now. So that's different problem. So now let's square both sides again. So always when you have a radical, you have to square both sides. That would help you simplify the problem. So squaring the radical again, they will cancel. We end up with 8x plus 9. But squaring the x, we get x squared. So now this is a quadratic equation. Every time you have x squared and x, that's a quadratic equation. And to solve it, we have to move everything to one side. Let's move everything to the right side. Subtract 8x, subtract 9. Subtract 8x, subtract 9. So this will come out, this cancels, so that's a 0. Here we have x squared minus 8x minus 9. Now we need to factor. Open 4 parentheses. We want two numbers. Their product is negative 9. Their sum is negative 8. So this is called the product. And the negative 8 is called the sum of the two numbers. So 3 times 3 is 9, but the sum is 8, so that's not going to work. How about 9 times 1? 9 times 1 is 9. Their sum could be negative 8 if we use negative 9 plus 1. So negative 9 plus times 1 is negative 9. Negative 9 plus 1 is negative 8. So we're done. So it's going to be x minus 9, x plus 1. So now we have to equate this to 0. Every time you equate two factors to 0, then one factor at a time could be 0. So either this one is 0, then x would be 9. If this one equals to 0, subtract 1 from both sides, x would be negative 1. Are we done? No, we're not, because we have to go back and check. Let's go back and check. Try x equals 9. If x equals 9, then you have 8 times 9 plus 9. Is it equal to 9? Because remember, x is 9, right? And we substitute x equals 9. So 72 plus 9, 72 plus 9 is 81. Is the square root of 81 equals 9? The answer is yes. So x equals 9 is one of the solutions. Good. So this satisfies. Let's try x equals negative 1. Square root of 8 times negative 1 plus 9, is it equal to negative 1? The answer is no, because that's a positive and that's a negative. A positive cannot equal to negative, but let's show the work. Negative 8 plus 9 is 1. Square root of 1 is 1. 1 does not equal to negative 1. So right away, x equals minus 1 is not a solution, and the only solution is x equals 9. Final answer. Let's find the product of two complex numbers. So 5 plus 4i is written as a plus bi, and this is called a complex number. It's a complex number because I is equal to the square root of negative 1, and I is not a real number. Square root of negative 1 is not a real number. There is no number, you cannot find the square root of negative 1, right? You cannot find the square root of, because 1 times 1 is 1, negative 1 times negative 1 is plus 1, so we cannot find the square root of negative 1. That's why this is a complex number. But let's just multiply. 5 times 9 is 45. 5 times negative 2i, negative 10i. 4 times 9 is 36. 4 times negative 2i, negative 8i. Oh, 4i times negative 2i. Okay, let me try again. 5 times 9, 45. 5 times negative 2i, negative 10i. 4i times 9, 36i. And 4i times negative 2i, negative 8i squared. Because we're multiplying I times I. Remember, if you multiply x times x, you add the exponents. I times I, you add the exponents. But if I equals square root of negative 1, then I squared equals negative 1. So replace I squared by negative 1. Let's see what happens here. Negative 10i plus 36, right? Negative 10i plus 36 is 26i. So 45 minus 26i. Now, negative 8 times negative 1, because I squared is negative 1, is plus 8. So what is 45 plus 8? 53 minus 26i is the final answer. So basically all what we did here is FOIL. 5 times 9, 45. 5 times negative 2i, negative 10i. 4i times 9 is 36i. And 4i times negative 2i is negative 8i squared. But I squared is negative 1, so negative 8 times negative 1 is plus 8. Negative 10i plus 36 is plus 26i. So this should be plus 26i, because this is more positive. So now 45 plus 8 is 53 and then plus 26i. It is very important to go over your work at least 2 times, because every time you'll find a mistake. So the more you go over your work, the more you will see the mistakes and you will fix them. So notice that here, plus 36 minus 10, we will subtract 36 minus 10 is 26. Now why plus 26? Because you have more positive. 36 is more positive than negative 10i. So that's a 26i. Now this is negative 8 times negative 1. That's a plus 8. 8 plus 45 is 53, and then 26i. So the final answer is 53 plus 26i. Divide and simplify to the form a plus bi. The only way we can divide here is when you multiply by the conjugate of the denominator. So let's go ahead and multiply up and down by the conjugate of the denominator. So we have 7 plus 3i, 7 plus 3i, over 5 minus 4i. Multiply up and down by the conjugate of the denominator. What is the conjugate? Here is the conjugate. Let me explain. If you have a plus bi, then the conjugate would be a minus bi. If you have a minus bi, then the conjugate would be a plus bi. So all we are doing is changing the sign. We change the sign to get to the conjugate. So in this case it's 5 minus 4i, and the conjugate would be 5 plus 4i. And then why do we multiply by the conjugate? Because of the difference of 2 squared. Remember, when you multiply a minus b times a plus b, you end up with a squared minus b squared. By getting a square here and a square here, what happens to the I? I becomes I squared, and I squared is negative 1. And therefore, no more i's in the denominator. We get rid of the I from the denominator, and that way we can write the equation as a plus bi. Okay, let's multiply straight across. 7 times 5, 35. So we start by 7 times 5. Then we multiply 7 times 4i, 28i. Then you multiply 5 times 3i, 15i. And 4i times 3i is 12i squared. So we finished from foiling the numerator. Let's go ahead and foil the denominator. 5 times 5, 25. 5 times 4i, 20i. Negative 4i times 5 is negative 20i. And negative 4i times 4i squared is negative 16i squared. So let's simplify. What is 28 plus 15? 38 and 5, 43i. Now that again the I squared will change to negative 1, and 12 times negative 1 is negative 12. Negative 12 plus 35 is 23. So that's the numerator. So again 35, and you have here negative 12. Let's subtract 3, 2. That's how we got the 23. 28 plus 15i, so 28i plus 15i is 8 and 5, 13. 2 and 1, 3 and 1, 4. 43i, and that's how we got the 43i. In the denominator, plus 20i minus 20i will cancel. Minus 16 times negative 1, because I squared is negative 1, would be plus 16. And 16 plus 25 is 41. Let's make sure this is right. 25 plus 16, 11, carry 1, 41. So notice now this can be written as 23 over 41, which is my A, plus 43i over 41, which is my B. So that's what they want us to write this in the terms of A plus B. And so A would be 23 over 41, and B would be 43 over 41i. That is A plus BI. So again, all we did in this problem is multiply by the conjugate of the denominator. The conjugate of the denominator, 5 minus 4i, is 5 plus 4i. So notice here we have a plus 4i. And now we can multiply straight across. So you're going to FOIL, multiply the numerator by the numerator, multiply the denominator by the denominator. You go straight across. Then you can simplify the I squared because it is -1. And then simplify also the denominator because these two will cancel. And 25 plus 16, because this is also a -16 times -16 will make it plus 16. So you add it to 25 and you get your 41. So any fraction you can split into two fractions. You have 23 over 41 plus 43 over 41i. Final answer. Another, rationalize the denominator. So in this case, notice we have a radical on the numerator and denominator. Since the question is to rationalize denominator, we can split the radical as square root of 7 over square root of 2i. And like we did in the previous problem, let's multiply up and down by square root of 2y. The reason for multiplying by the same one, because that will turn to a perfect square, and the radical with a square root will simplify. Multiplying the numerator, you end up with square root of 14y. We can multiply the inside because both of them have radicals. We can also multiply the inside here because both of them have radicals, so the denominator becomes 4y squared. The 4 will come out as 2. The y squared will come out as y. So the final answer would be square root of 14y over 2y. Okay, we cannot simplify anymore, and this would be the final answer. So our target in this problem to remove the radical from the denominator. Remove the radical from the denominator, and that's the final answer, is 2y in the denominator with no radical. And all we did, we multiplied up and down. Now what's good about multiplying up and down by the same number? As if you are multiplying by 1, because any number divided by itself is 1. But once you multiply, you have to multiply straight across. Since both of them are radicals, you can multiply the inside. 7 times 2y, 14y. 2y times 2y is 4y squared, because here we have to add the exponents. 1 plus 1 is 2. A square root of 4y squared. 4 is a perfect square, will come out as 2. Y squared is a perfect square, will come out as y. So the final answer is square root of 14y over 2y. Alright, that's it.